So for part B of the first question, it wants us to show that the magnitude of a cross b squared is equal to magnitude of a squared times magnitude of b squared minus the dot product of a dot b squared. So to start, we need one formula where we know that a cross b magnitude will be equal to a b sine theta, but we have a square. So that means if we square both sides, we get magnitude a squared, magnitude b squared, sine squared theta. So this part right here looks a little bit like this part right here. So what we can do is we know that this sine theta, if we pull it out, sine squared theta, the sine squared theta must be equal to 1 minus a dot b squared over magnitude a squared magnitude b squared. And we know that because we have this a squared b squared. So if we pull that out, we would get 1 minus a dot b squared over the magnitude a squared magnitude b squared, because they would cancel out. So if we're going to simplify this, we know sine squared theta is equal to 1 minus a dot b over a b, and all of this would be squared. So what we also know is a dot b is equal to magnitude a magnitude b times the cosine of theta. So if we replace that, we get sine squared theta equals 1 minus a b cosine theta. That's all squared. Then we have, we can actually bring this square out, and we get a b, and all this is squared. So if we distribute that square back into our equation, we get 1 minus a squared b squared cosine squared theta over a squared b squared. And we notice that these squares cancel. So now we're left with sine squared theta equals 1 minus cosine squared theta. And because of this, from Pythagorean's theorem, we know sine squared theta plus cosine squared theta equals 1. So this theorem that we just got proves what we're trying to find. If we subtract cosine squared theta on both sides, we get that sine squared theta is equal to 1 minus cosine squared theta, which is the same as this. Therefore, we proved that a cross b squared is equal to a squared b squared minus a dot b squared.